Hello friends, welcome to Susan and John MathTube. In this video, we are going to learn about our normal distribution. In the last few videos, we saw the binomial, the Poisson, hypergeometric and negative binomial, which are special cases of the discrete distribution. And in this video, we will be discussing a special case of the continuous distribution, and that is our normal distribution. And you can see a few graphs here, and all the graphs follow the bell shape. So basically, the normal distribution has a bell-shaped graph. Okay, now I'll tell you the importance and how it comes. By the way, the word normal itself suggests it's very common. You can see it everywhere, and that's exactly why it was named normal distribution. It's just a normal event. Okay, and the best way to understand this is by checking the height of the people who are living in a same community. Okay, now just imagine you went into the city and you see many people in the city. Just ignore kids and we are talking only about grown-ups. Okay. And if you look at the height of the people, let's say we go to a marketplace or we go to a mall or anywhere. Now you think about the height of the people who you saw. Okay, I'll mark in centimeter. Let's say this is 50 centimeters and 100 and 150 centimeters and 200 centimeters and 250 centimeters, etc. So let's say I met 2-3 people of height 125 centimeters. So this is the number of people. So the graph will go like this. And I met like maybe 50-60 people who are 150 centimeters tall. And now what happens is you're going to end up with a graph like this. I'm sure about that. If you want, you can go and check it yourself. You're going to get something like this. It'll go asymptotically towards the x-axis. So what happened here is, you know that most of the people will be having height in this range. Most of the people will be somewhere around this. And of course, very few people, maybe you won't even meet them that day, will be extremely tall. So there is a small possibility. And this is our normal distribution, and that's exactly why you get that bell shape. Okay, I'll give another example. Let's imagine the mileage of a vehicle. Let's measure like kilometer per liter of fuel. So think about, you use 1 liter of fuel and measure how much your vehicle runs. You again take 1 liter of fuel and check how much your vehicle runs. Do this again and again and again and again and again. And I'll guarantee you're going to get the same graph again. Sometimes, unexpectedly, the mileage will be very high than you expect. But that's a very rare case. And sometimes you'll be getting very less mileage than you expect. But majority of the times it will be somewhere over here. It will be almost the same value. And there is another example of normal distribution. I'll give you one more example. It's about popcorn. If you try making popcorn at home, you'll notice one thing. Initially, when you apply a little bit of heat, some of the corns will start popping. Not every, maybe 1 or 2 or a few will start popping. And then what happens is, almost all the corns start popping, and it will peak, and then the popping slows down, and you might turn off the fire, you might turn off the heat, and again a few of them will pop, and that's it. So here again the bell-shaped curve appeared. And one last example. let's say you measure the length of leaf of some particular plant, and the length of leaves are not uniform. Some leaves will be a little bit longer, some will be shorter. But if you measure the length of leaves, you'll see that majority of the leaves are almost having the same length. And of course, a few will be very long and a few will be very short. See, again that bell-shaped graph. Okay, now you got a rough idea what is this normal distribution. Okay, so whenever we discuss about things which happen very frequently in the middle, extremely less frequent when it goes to the extremities, that is called a normal distribution. And the probability distribution function for the normal distribution is given by 1 by root 2 pi, and sigma is outside, e to the power minus of x minus mu the whole square by 2 sigma square. So you remember this probability distribution function. So and another interesting fact the statisticians have found about the normal distribution is the total area under the graph. It's a PDF, so you know about the total area because the property tells you interval minus infinity to infinity f of x dx is equal to 1. So according to this property, the total area is 1. Okay, now the specialty of normal distribution is this area will be equally divided on both sides. That means if you find the area from, let's say, this particular point to infinity, or if you find the exact negative, let's say this is like t, and if it is like minus t to minus infinity, the area will be same. So it's a symmetric graph, it's symmetric. And this midpoint will be mu, the mean of the distribution. Okay, and this side area will be half, and this side area will be half. So this is one specialty of the normal distribution. And another interesting aspect, in a normal distribution, we have the midpoint as the mean of the distribution. And if you add, or if you look at the interval mu plus sigma and mu minus sigma, this will contain approximately 68% of the area. This interval will contain approximately 68% of the area of the graph. And if you consider the interval mu minus 2 sigma, mu plus 2 sigma, that will contain approximately 95% of the area. And if you add one more sigma and subtract one more sigma, then it will contain 99.7% of the area. So this is how a normal distribution behaves. Okay, now we saw, and you can think about more examples which are related to the normal distribution. This function looks a little bit complicated. So if you want to find probability in a normal distribution, the integration is going to be really tough. You'll have to use beta gamma functions, etc. So let's put it in a simple way. The integration is tough. So what we do is we create something called the standard normal distribution. So given any normal distribution, let's say a normal distribution with parameters mu and sigma, because you saw the formula, the function is controlled by mu and sigma. Mu means the mean of the distribution and sigma is the standard deviation of the distribution. So we write x follows n mu sigma, or some people write x follows n mu sigma square. You just follow the pattern in your book and make sure whether this is standard deviation or variance. Okay, so if you have a general normal distribution, okay, let's imagine we are talking about the mileage of vehicles. So we have the origin here and the graph over here. And let's say in the next experiment we are talking about the popping time of popcorn. Okay, we get a normal distribution, but the graph will be placed somewhere else. So in every experiment we will get the normal distribution here and there. So to make a unique distribution, what we do is we standardize the distribution. That is, we do a simple mathematical transformation. We use the operation x minus mu by sigma. You know that in a function, okay, I'll give an example. Suppose we have a function f of x equal to x square, and that represents a parabola. And if you replace our x with x minus 1, then you're going to get the same graph, which will be shifted 1 unit in the positive direction. You're going to get the same graph which shifts 1 unit in the positive direction. And when you apply that logic over here, the graph will get shifted according to the value of mu. And if you replace f of x with f of 5x, okay, that's going to give you 5x the whole square. Or let's say you multiplied this graph with 5. The graph is going to get stretched. So when you divide by sigma, according to the value of sigma, let's say sigma is 1 by 10, so the whole thing will get multiplied by 10. Or let's say sigma is 2, so the whole thing will get divided by 2. Anyway, you apply this property to any normal variable x. You apply this property to any normal variable x, we will get something called the standard normal distribution. And the standard normal distribution means it will be symmetric about the origin. So half the graph will be on the left side of the y-axis and half the graph will be on the right side of y-axis. And I'm sure that you have the statistical tables. And in the statistical tables, what they do is they provide the area from minus infinity to any point you desire. For example, the table provided by your university will be divided into two parts. One is called the negative score and the next one is called the positive score. So suppose you want to find the probability from minus infinity to, let's say, 3. So all you have to do is you have to take the positive table, and find the number 3.0, and here it will be written 0.00. Just find this value, that will be denoted by f of 3 because it's a cumulative distribution. Anyway, I'm going to wind up this video now. In the next video, we'll be doing a lot of numericals related to normal distribution which comes in your exam. So till then, bye.